Hi, and welcome to Blueprint to Reality. Today, we're tackling a question that's shaping the future of construction. How do you create a sustainable building framework? In just 3 minutes, I'll guide you through the principles, materials, and strategies you need to consider to design eco-friendly, efficient structures. Let's dive in. What is a sustainable building framework? A sustainable building framework is a structural system designed with minimal environmental impact. It prioritizes energy efficiency, renewable materials, and long-term durability while reducing waste and carbon emissions. Think of it as the backbone of a building that supports not only the structure, but also the environment. Choose eco-friendly materials. Start with sustainable materials. Bamboo, cross-laminated timber, and recycled steel are excellent choices. These materials are renewable, durable, and require less energy to produce compared to traditional options like concrete. Using local materials also cuts down on transportation emissions. Design for energy efficiency. Focus on energy-smart design. Orient the building to maximize natural light and ventilation. Incorporate insulation that reduces heating and cooling needs. Structural elements like green roofs or solar panel-ready surfaces can further enhance energy performance while aligning with sustainability goals. Build for longevity and flexibility. Durability is key. A strong framework reduces the need for repairs or replacements, saving resources over time. Additionally, design with adaptability in mind. A framework that supports modifications ensures the building remains functional as needs evolve, reducing the need for demolition. Conclusion: creating a sustainable building framework requires thoughtful material selection, energy-efficient design, and durability. By implementing these strategies, you're not just constructing a building, you're contributing to a healthier planet. Ready to build sustainably? Let us know your thoughts in the comments. Thanks for joining Blueprint to Reality. Don't forget to like, share, and subscribe for more civil engineering insights. See you next time. Predict structural failure before it happens. Imagine walking across a bridge when, suddenly, a crack forms beneath your feet. It might seem like an accident waiting to happen, but what if I told you that structural failure is rarely a surprise? Behind every collapse is a series of warning signs, stress, strain, and fatigue that engineers can detect before disaster strikes. Today on Blueprint to Reality, we'll uncover the science of predicting structural failures, how it works, why it matters, and the tools that make it possible. What is structural failure? Structural failure occurs when a building, bridge, or any other structure can no longer support the forces acting on it. This isn't always as dramatic as a collapse. It could start as a small crack, a slight tilt, or a vibration that feels out of place. For example, the Tacoma Narrows Bridge didn't collapse without warning. It began with oscillations caused by wind, which engineers later identified as aeroelastic flutter. This failure wasn't just about materials, it was about how forces interacted with the structure. Predicting failure involves understanding these forces and how structures respond to them. Factors include material behavior. Will concrete crack under pressure? Will steel bend under extreme loads? External forces. Wind, seismic activity, and even temperature changes can push a structure to its limits. Structural design. The shape, size, and distribution of weight determine whether a structure can withstand applied forces. Types of failures engineers look for. 1. Elastic failures. These occur when a structure deforms under load but doesn't immediately break. For instance, a slender column might buckle when compressed beyond its critical load, a phenomenon known as Euler buckling. 2. Dynamic failures. These involve vibrations or oscillations that grow uncontrollably. The Tacoma Narrows Bridge is a classic example, where wind-induced resonance caused the structure to tear apart. Both types of failures can be catastrophic, but they're also preventable with the right tools and techniques. How engineers predict failures. To prevent structural failures, engineers rely on cutting-edge tools and methods to identify risks before they escalate. Sensors and IoT. Smart sensors monitor stress, strain, and temperature in real time, acting as the structure's nervous system. Finite element analysis, FEA. This computational tool simulates how structures respond to forces, providing insights into weak points. Resonance testing. By identifying a structure's natural frequencies, engineers ensure it doesn't resonate with external forces like wind or earthquakes. Non-destructive testing, NDT, techniques like ultrasound or X-rays help inspect internal weaknesses without damaging the structure. With these tools, engineers can predict not just when but where failure might occur, allowing them to intervene before it's too late. Real-world applications. These methods are already making a difference. In Japan, seismic sensors send real-time alerts during earthquakes, giving people time to evacuate. In Switzerland, AI algorithms monitor snow loads on cable cars, preventing potential failures. And in skyscrapers worldwide, wind tunnel testing ensures stability in extreme weather. Why predicting failure matters. When we predict failures, we don't just save structures, we save lives, resources, and ecosystems. A collapsing bridge or building can cause tragic loss of life, cost millions in repairs, and devastate the environment. But predictive engineering also enables innovation. From earthquake-resistant buildings to windproof bridges, understanding failure allows us to build structures that push boundaries while staying safe. Conclusion. So, how do we predict structural failure? By combining engineering principles with advanced technology, we can detect problems before they become disasters. Thanks for tuning into Blueprint to Reality. If you found this breakdown insightful, don't forget to like, subscribe, and hit the bell for more engineering stories. Until next time, stay curious and keep building one stable structure at a time.